Hello everyone. Today we are going to learn a very important concept of eigenvalues. That how you can find the eigenvalue, what are eigenvalues, and what is eigenvector, so that you can easily calculate it. You should have the concept. So first of all, I will tell you what is eigenvalue and eigenvector. Then we will use a step-by-step process to find the eigenvalue in today's lecture. So I have already written a matrix that is of the order 2 into 2 because it has 2 rows and 2 columns. And before finding the eigenvalue of this matrix, we will see what is eigenvalue and what is eigenvector. So eigenvalue is basically a scalar value. Scalar value means it has a magnitude only, it has no direction, and it is used to transform the eigenvector. So it is used to transform the eigenvector means it is used to scale the eigenvector will be scaled by this eigenvalue. Or you can say scalar. It is a scalar value that basically represent how much the eigenvector will be scaled. So this is the scalar value and it is represented by lambda. While eigenvector is basically a vector that does not change its direction even after the linear transformation. Linear transformation means after rotation, after scaling, after reflection, it will not change its direction. It will only scale by the how much it will be scaled. It will be scaled by the eigenvalue. It means we must know what is the value of eigenvalue so that we can have the understanding that the eigenvector, that how much the eigenvector is scaled. So this is basically a vector that does not change its direction even after linear transformation, and it is basically represented by vector v. So this was all about eigenvalue and eigenvector. Let's start a step-by-step process that how you can find the eigenvalue of this given matrix. So first of all, we must know the characteristic equation. So that equation will help us to find the value of lambda. So what is the characteristic equation? So whenever you will be asked to find the lambda, you should know the characteristic equation. The characteristic equation is basically is like this. Determinant of vector A minus lambda I equals to 0. So this is the equation. Now what this equation is representing, A is basically lambda is the eigenvalue and I is the identity matrix. So in this given question we have all. We just need to find the eigenvalue, rest we already know. Identity matrix is all depends on what is the order of the matrix. If it's 2 into 2, you should have the 2 into 2 identity matrix. If it's 3 into 3, you should have the 3 into 3 identity matrix. So what is the step number 2? You just need to put the given values in the formula. So how we can do this, we will just do right here determinant of, I will write the given vector A, that is 0, 3, minus 2 and 4. So this is the given vector minus lambda and the identity matrix, that is 1, 0, 0, 1. So in the step number 3 we will just solve it. So I'll replace determinant with the, you can say, these bars that is also represent the determinant, and I'll just multiply them and minus. We will multiply the lambda with lambda here with this matrix, and then we will subtract this matrix with the from the given matrix A. So I'll write here 0 minus lambda. We will subtract the corresponding entries from each other. Minus 2 minus 0, because when lambda multiplied by 0 it will be 0. Then 3 minus 0 and 4 minus lambda. It should be equal to 0. So what we have to do now, we have to take the determinant of this. What will be the determinant? First I will write the simplified form, that is minus lambda, 3 minus 2 and 4 minus lambda equals to 0. Then what we have to do, we have to take the determinant of this 2 into 2 matrix by just multiplying the diagonal entries and subtracting it from each other. So I will do it here. Minus lambda into 4 minus lambda minus 3 into minus 2 equals to 0. Then what we have to do, we have to solve them as minus 4 lambda plus lambda square plus 6 equals to 0. We will arrange it in the form of quadratic equation. Lambda square minus 4 lambda plus 6 equals to 0. Now this is a quadratic equation and we cannot factorize it easily. So we will use a quadratic formula to find its factors, or in other words, the value of lambda. So I'll draw a line here and I'll solve it further. For lambda, lambda is equals to minus into minus 4 plus minus underscore. I am using the quadratic formula, that is minus b plus minus underscore b square minus 4ac divided by 2a. So b square here will be minus 4 whole square will be 16 minus 4. Keep this in mind, the value of lambda can be real and it can also be a complex number. So 4ac, a is 1 and c is 6 divided by 2a. 2a is 1, so it will be 2. So 4 plus minus under root 16 minus 24, it will be minus 8 divided by 2. So the roots will be 2 plus minus under root, or you can also further simplify it. It all depends on you. So this is basically a method of finding the roots, method of finding the eigenvalue of a matrix that is of the order 2 into 2. So it all depends on that what is the order of the matrix. If it's 2 into 2, you have to use the identity matrix with the order 2 into 2, and you just need to solve them together and you will get the eigenvalue. So these values, this is a scalar value, and this scalar value is, so it's a complex scalar value as there is a iota also there. So these scalar values are showing that this is the eigenvalue and this is the scalar factor by which the eigenvector is basically scaled after the linear transformation. So that's all from today's lecture. In my next lecture, I will tell you how you can calculate the eigenvector. So that's all from today's lecture. Thank you.